This conference will now be recorded.
So you can ask if you have any one of you have any questions, you can ask. Nobody have questions. Great.
Sir, in the WhatsApp group, one of our guys have asked a question for the parameters or attributes and functions are for arguments. Can you explain that part?
Okay, explain it again. Okay, cool.
Not the whole thing, but the difference between the two of them.
Yeah. Okay, so I was giving you this analogy as an example. So for now, I mean, you can treat them as it is, but they are actually not. They are a little different. There is a difference between them. So as I said, let's say that this car is my object, and I gave it a name, maybe this car, I gave it a name, some name. So the state of the car is going to be the attribute of this car, which is going to change over time. The mileage of the car might change, may change over time, over some years. The engine, the power of the engine might decrease or increase, whatever it could be. The corrosion will happen, the parts will corrode, so many things will happen,
Yes.
the stress and strain on the engine, so many things happen. So over time, the engine capacity or the power of the engine will decrease, the mileage might decrease, and also the amount of fuel over the time, passage of time. If you're traveling from maybe from Bangalore to Delhi, so obviously it's not going to remain the same, it's obviously going to decrease. So that is the state of that particular car, and the state is called as attribute. If I say this car is my object and it has some features, or so it could be mileage or amount, so these are the attribute basically of that particular car. But when I talk about the behavior, the method, so that is going to be, that is going to be the method, you can say. So that's what the question, right? The attribute and what was it, parameters you were saying?
Parameters are for attributes and functions are for arguments.
Oh, what was the question? Parameters and what? Oh, it was parameters and attribute.
Yeah.
Okay, so attribute basically, attribute basically is the name that we give it to, the particular thing. I'm calling for the attribute, and this is it. Okay, let's say, how do I explain it to you? Okay, so let's imagine that you have a phone, right? You have a phone. So everything
Yes.
in Python, as we say, is an object. So you have a phone, so that is an object. If I create your phone in my Python language, if I am creating an application for your particular phone, that this application is going to push out for this particular user. So how will I decide that? How will I create the difference? Because I will not have only one user. Okay, let's not go there. That's going to be, I mean, okay, let's say you have a phone, I also have a phone, and all the 10 guys who are uh, in this conference right now, they do, all of them do have a phone. But how we are able to differentiate you have which phone, I have which phone, how we are able to differentiate? We are able to do that with the help of specification, right? So the attribute would be the specification. Might be you have a color. I will say you have your phone has an attribute color. So then you will tell me now what is the color of that attribute. So that is
Yes,
going to
sir.
be the thing. That is going to be the other thing which I was saying. Attribute basically the name of that particular argument, and then the other one is the value that we are passing to that thing. And with which this thing only, with attribute, we are able to create the difference. If you will tell me I have a phone of red color, maybe if somebody says I have a phone of black color, and if somebody says I have a phone of maybe sky blue, or maybe sea color, or whatever it could be, I mean, so with this I'm able to draw the differences. So that's how it works basically. So the value that I pass into the attribute, basically, that is the other thing. And for whichever, for whichever the value or attribute, you can say it's a variable. I'm giving it a variable for some specification or some feature if I want to extract them. So it's sort of a variable, but we are defining in terms of object when we are creating our own object basically, then we call it an attribute. So that is the difference, I guess. Is
Okay,
it
sir.
clear, or is it more confusing, more
No, sir, it's kind of clear.
kind of
With
clear?
more
Okay.
examples, maybe I'll be able to understand.
Yes, yes, yes. You know, it's something new to you. You know, that's why, you know, it takes time. You know, to get the gist of it. That's why it takes time. Anybody
Yes,
have
sir.
any other anybody have any other question? Nobody have a question. Okay, great. So today we're gonna do the regression analysis again. So let's see. Tell me something more about NumPy. Yes, we will look into that, Sunidhi. We will. We will. Maybe tomorrow, in tomorrow session, we'll look into that. See, I can take this training in 2 modules. Either I can just teach you the concepts, create functions, and that's all. You know, related to the conceptual knowledge, I can give you, or either I can make it more related to the projects. We can try creating project, and then we can do the project based learning. That is what I thought. Make it a project based learning. But if all of you agree to this, that you only want to learn the complete concept from scratch, then that is also possible. I mean, then I will just teach you the basic concept. I mean, how NumPy works, how you can create different things in NumPy, you know, cross section, intersection, all those things. If all of you agree to that, we will not go into project from tomorrow. No project function is right. So what everybody says, you don't want projects, you don't want to work on the projects, just want to get the basic knowledge. So two things are not possible, huh? In 10 days, you know, how can we cover all these things? So yes, that's what I'm doing, Harshita. I'm working on projects so that project-based learning can be given. Whatever is required in that particular project, I'm trying to explain you that particular thing, so that you will have some projects as well, and you'll have some understanding as well. Projects, right? So that's what I thought. I mean, projects would be good, right? So that is what I'm trying to do. I mean, trying to give you understanding from the basic project, so that, you know, I don't want to jump into a project which have a maybe 40 variables, 30 variables, and then I try to explain it to you, and you know, you won't get it. I mean, I want to take things slowly, and so that you can find the relativity and you can understand that particular project that we are working on, right? Otherwise, I will take maybe 1 day for NumPy, 1 day for Pandas, 2 days for maybe Python, and 1 days for Matplotlib visualization, and 1 2 days for machine learning, 1 2 days for I mean, for deep learning. So that will be all conceptual. So I don't want to do that. I want you to get best out of this training, and that is also only possible because of the project. Because we are doing end to end, no? We are collecting data. I'm showing you the data also. We are doing the data visualization, data manipulation. Then we are putting a model on that. Then we are getting our calculation. So everything we are doing from the basics. So I think you'll have more clarity on that. Okay, so we are going to do a regression analysis again. So I have collected the data. I think you have seen this data before, the LSD data that we were trying to work on. If you can recall, maybe it was it was on Friday that we were working on. Do you remember that data, particular data in which I said I will talk about this data in the coming section? If you could remember that. If not, then I will show you. All of you remember that or not? No, you don't remember? Okay, let me show you that. So this was the notebook that we've created, now. Okay, let's go back. Okay, yeah. Okay. Okay, yeah. So this data, do you remember this? We've done a lot of operation on this particular data set. So we have time delay in minute, we have a LSD ppm, we have average maths test score. I hope you remember this. We extracted data frame from it. We talked about series, how to add values, how to do. More noise is coming. Is it same for everyone? Is it any better? Ashima, is it better? Are you still getting the background noise? Ashima, is it better? Okay, great. No. Okay, no, you're not getting the background noise. So I hope you remember this. We've done a lot of operation on this particular data set. So today we are going to understand more about this data set, and we'll try to apply the linear regression model on top of this. Okay. So let's go jump back to the slide and let's try to understand what this data set is, how this data set is collected, what are the different values are for. So let's try to see. So this data set was collected maybe around 1995 or something, that around that time. Basically it was an experiment which was conducted in US, and it was an experiment, if you say, it's a correlation of performance of test score with the tissue concentration of yeah, some name. So basically what this experiment was conducted by John G. Wangler and George K. Afghan, something of that sort. That was the name of the person or the PhD scholar who conducted this test basically. So what they did with this test basically, they collected, maybe they have 5 volunteers, and what they did with them basically, they injected them with some concentrated drug basically, and it was completely intervened, and they have all the permission to conduct this test. So they injected the drug based on the weights and the height of the volunteers. What is going to be the concentration of the drug? It depends on the height and the weight of the volunteer, whoever it may be. So the name of the drug was something like lysergic acid diethylamide. If somebody is from chemistry, please don't kill me. I am not able to pronounce this correctly. So it is LSD 25. If you go Google LSD 25, it's a very good hallucinate, for the hallucination. You can see it's mentioned there, LSD 25. So that was the LSD 25. That was the column that we have, LSD 25. So they collected the data, and let's look at the data now. Okay, where is it? Where is it? Okay, yeah, here I have, yeah. So they collected this data. So what are these different values are? Because before applying any machine learning model, it's very important that you know about your data, that what your data is, what are the different columns are trying to tell you, is what is the story of this data basically. You should be aware of that particular story of a particular data set that you are using. Okay, so here I have time delay in minutes, then I have LSD ppm, then I have average maths test score. That was the data set that I have, and I hope you all have this data set with you, and I will ask you to import it and store it in a variable called as data. So what are these values are for? So let's look at this. So first of all, this is time delay in minutes. Let's look at this. So it says 5. So what is this 5? So this 5 means they injected a volunteer with some drug that I've talked about, LSD 25. They injected that person with a drug, and they gave him 5 minutes, and after 5 minutes they checked the LSD ppm, basically what is the concentration of LSD in the tissue. Then they asked him to sit for the score. All of the guys, I mean 5 guys, they asked him to sit for the test score. They gave him some question and they asked them to solve those particular question. Then they gave him again, all of them, maybe the volunteer, after a drug again after 15 minutes, and then they check the concentration. It's approximately 2.97, approximately 3. Then they asked them to again sit for the test for 5 minutes and to solve the question related to mathematics. And then again after 30 minutes, then after 1 hour, then after 2 hours, then after 4 hours, and then after so on and so forth after 8 hours. So you can see the LSD concentration or the LSD tissue concentration is increasing, and we can see clearly that the average score is decreasing. So the hypothesis is very clear that whenever there is a LSD concentration or the tissue concentration of LSD in the tissue increases, the concentration is going to go down. I mean, they cannot concentrate, they cannot focus, they cannot perform well in the exam. That was what I can interpret from this particular data set. Might be you have some other interpretation, then you can put them on the chat window. I would definitely have a look at them. If you have some other interpretation, what do you interpret from this particular data set, you can tell me. So let's try to understand what is this LSD score average, how it could be average, what they did, I mean how they got the average. Let's try to understand that. Okay, so let's see. Yeah, concentration is there. So how that average came into picture, let's see. So what they did basically, let's say there were 10 questions that was asked in that particular test, and this was the correct answer by the controller. Then they have how the average people answer those questions, how many correct answer. If the same question are given to an average person, how many questions they answer correctly. So let's say that is 9, but how many questions are corrected by the volunteer? Let's say they are 3 maybe. So what is the average coming out to be? It's coming out to be 33, because 3 by 10 is 33. I guess all of you are that well with the mathematics. So that's why we have up here at this point 33, 32.92, right? So I hope this makes clear, and now we are aware that what exactly this data set is. Okay, are we aware of that? Are we aware what exactly this data set is doing? No responses. Then what I'm going to do, I'm going to import pandas as PD, and I'm going to store my data in this variable, which is, yeah, you also do the same thing. Data is equals to PD dot read underscore CSV, and I pass the name of the file. What is the name of the file? Yeah, this is the name. Now when I go run it, say print data. Yeah, no, this is, sorry, my bad guys, this is not the file what I want. I want the LSD math score file. So sorry. Okay, yeah, so this is the file I want basically. So it is clearly visible that the motive of the experiment was to find the relationship, that if there is any relationship between the LSD ppm and the average test score, and based on the time delay. So this is what we are going to do. We are going to create 3 variables, and we are going to store these value in those variables. And I guess I have explained you about this. How can we extract these columns from a particular data set? So let's call it to be maybe yeah, call it to be LSD, and then data, pass in the column name LSD ppm. If I go run it, it should work. Yes, I can also score, just score maybe average math score. I'm going to store at this variable, and please don't make any typos. Score in this. Also, if you want, you can store time, but we don't really require time. If you want, you can store it, but we are not going to use it. So this is time delay in minutes. So it's okay. What is the error? Data, time delay in minutes. Time delay in minutes. S is there, no? So see, I told you don't make any typos. If you do, you will get this amount of errors. You can see this is the error you will get, and you will keep scratching your head and you won't know what exactly happening here. So please don't do such mistakes. Now let's check LSD, go run it. This is how it looks. Let's go check score. This is how it looks. Two of them, we need two of them. Now what I want to do, first of all, I want to plot these data point. And for plotting, if you remember, we had a library which was matplotlib, if you could remember that. So I'm just going to make that import matplotlib, and the linear regression I'm going to use. So I'm also going to make that particular import. This here, so you can type it. I'm also going to type it for you from matplotlib.pyplot as plt, and we are also going to import linear regression just like we did in the first model. When we ran the first model, sklearn.linear underscore model import linear regression. Yes, pyplot matplotlib as, what is wrong? Okay, see, my bad, import I have to say. Yeah, so you guys did this import because we would require this matplotlib library if you want to do the visualization. So are we on the same page? Have you imported this? You didn't get any errors? Can we move forward and try to plot it? Great, that's great. Now, no errors. Lovely, lovely to see that. Now, we have seen this, we have done this. Also, we can do data.describe. It's not really useful for this kind of data, but when you have a large amount of data, this data.describe helps you a lot. So this is again a method, as we say. This is the object and this is a method for that particular object. And the difference, I have shown you the difference basically when you are confused between the what is the attribute, what is the method. So a method will have the round brackets. So let's see. So this is telling me that in the time, this will have some these parameters basically. This will return count, mean, SD, mean, 75, minimum 75, 50, 75 max. So what are these? Okay, let's try to understand them. I told you again, this is not useful in this case, but yes, it is going to come into picture when we deal with large data set. This is just to give you the understanding of this sort of methods that we have, so you can use them. So basically it's telling me the count. How many values are there for the time delay? There are 7 values. How many values are there for the LSD PPM? How many values are for, so they have same value. What is the mean for time delay? It's 135. What is the LSD PPM? 4.33. What is the average score? 50. What is the standard deviation? And what is this for standard deviation? What is this? I guess you all are aware of standard deviation. What is the minimum value? Minimum value, minimum value. Sorry guys. Now 75%. So 75 percentile. So what does this mean? So let me try to give you understanding. So basically, let's say this is my data set. It follows some distribution. So that data set will be divided into 4 parts. This is going to be a 25%. This is again going to be another 25%. This is again going to be 25%. This is again going to be 25%. So they are saying that 25% of the data comes here. Then they are saying 75% of, sorry, 50%. That means this and this is in this range basically. Then they are saying 75% values. That means values may be starting from this point going up till here. It is coming out to be this point. And then they are saying the maximum value, which is at this point, is going to be this value. For different, you can have different curves. I mean, you can have a curve for time delay, you can have a curve for LSD score, you can have a curve for test score also. And the minimum value for it, it's this point. From where the minimum is obviously from where the point is starting, the maximum up till which the curve is going. So this is, we call it to be a bell curve, which follows a standard distribution or normal distribution. So I guess it is clear to everyone that what exactly this data is telling me. It's telling me about the distribution of my data, how my data is scattered, what are the minimum values, 75%, standard deviation, and all that stuff. Mean, I guess mean is aware, it's a middle value. Standard deviation, it's the difference between the two values basically. Cool. Now what we are going to do, this next step that we are going to follow is we are going to plot this data. This is the plot that we are going to do, and I will break down this code for you, what exactly this chunk of code is doing, what line by line. Okay, so we'll also look into how can we do, you know, more things with this sort of code, right? How do I know about this code? Basically, I will also talk about this. Okay, so first of all, I want to do the plot. For plot, I will use this. I'll simply just say plt.plot, and I will pass in the two values with the time and with the LSD. How the you know LSD concentration increases or get affected with the passage of time. So that's what we will check. So I'll just pass time. That is why I have created a different object from this. If you can see LSD time. So I'm gonna say time, and then what I'm gonna say, I'm going to say LSD, sorry, LSD, then I'll say plt dot show. So let's see. So this is the data point, or this is the sort of graph that I receive. So over here on the x-axis, I have what? What I have on the x-axis, can somebody tell me? What do I have on the x-axis and what do I have on the y-axis? As you can simply look at the values and I guess you can clearly tell what is it on the x-axis, what is on the y-axis. So tell me please, what is on the x-axis that you can interpret? Right, absolutely, Komal. So time is on the x-axis and LSD is on the y-axis. Absolutely, absolutely, right. So let's do one thing and let's try to look at this LSD plot. Sorry, this PLT dot plot, and let's try to understand what sort of parameters we can pass. Let's take the help of Google. Let's type matplotlib dot pyplot and let's open it up. So this is the documentation for the matplotlib.pyplot. So we'll try to see what are the arguments that I can pass. So can you see this? Let's ignore this first of all. Just look at this. So it's saying I can pass the x value, then some or none data, then it's saying quarks. And then if you go down maybe, then it will tell me that I can also pass some args basically. So let me show you if there is anything which is args. Yes, as you can see, it's saying args and quarks. So what is this args and quarks? So whenever you go to documentation and try to read something, you most of the time you will find this args and quarks with this asterisk mark or you say star. So what are these basically? So args means arguments or multiple arguments. When we try to create our function, we define the arguments, right? The first time when we created the function, we defined the argument that this is going to be the input that I want to give. But let's say I have like multiple inputs. I have multiple arguments in my function that you can do many things with my function. And I don't want you to expose with all those values. I want to give you the opportunity or the option that you can opt for those values. It's going to be completely your choice whether you want to opt for those values or whether you don't want to opt for those values. That's completely going to be your choice. But if there are going to be some argument that you need to pass which are going to be mandatory for a particular chart obviously, but you can do a lot of things with arguments. So you can relate it to something. Let's say maybe I have 20 arguments. Out of those 20 arguments, I am saying you can use my function with 20 arguments. So with 20 arguments you can do lots of things. But out of those 20 arguments, I'm just saying only 2 are mandatory. That means if you will not pass the 2 arguments, you will not get anything. And if you pass the 2 arguments, you will get something. If you pass more than 2, obviously you'll get something better. Or you can choose according to your need or according to the time that you are using that particular thing. So what is this keyword argument? So keyword argument is basically something when we have a keyword and we enter the value for that particular keyword. I guess when I was explaining you about the function when we were creating the function, so yeah, so this is something of you can relate it to keyword argument. This is a keyword argument that I have to pass a value to this particular thing. I mean, I've talked about this. Yeah, see, I'm passing the value. Now, destination is equal to easy day. So in that way, I will have different keyword argument. Maybe color I have, maybe line width. Maybe I have alpha. I have figure size, or lots of things I have. So this is what args is, and this is what quarks is. That means having multiple arguments and having multiple keyword arguments. So all the functions of matplotlib will have these two things. But we just want to look at these arguments and trying to find out which is the argument that is going that is going to be useful for me. So these are different one that I have. Okay, I don't know this. No. Okay, no. I mean, this documentation is huge. So, this is how, I found out about these arguments, that what are the different arguments in these. So, what I did, I found out one argument, which is the color. And so let me try to see if I can search for it. So color, see, there are hundreds of colors are there. I need to go for the code. They have a color code, that how you can use a particular color. Okay, let's leave it for now. I'm not able to find it. So now let's say I want to give my line, because visualization is going to be always an essential role for you, to present your data in a good way, that somebody can look at that data and try, he feel interested to know more about that data. The colors are very good, and they have very good contrast, and that's what it's going to be very, very important when I say about visualization. That is a very important aspect of visualization, interpreting the data and explaining about the data and putting in a good way or the right way. It's always very essential. Yes, somebody was saying something. Somebody was saying something. No one? Okay, great. So now what I'm going to do, I'm going to use the color. This is my keyword argument. This is the keyword I'm using, and I'm passing it some value. Maybe if I say G, let's see what happens. So this is cut for green. If I pass maybe some other colors, then it will work according to that. B, if I pass, it will work according to that. If I pass R, it will work according to that. If I pass Y, V, no V is defined. So I can only pass the arguments which are defined in the documentation. Also, if I want to increase the line width, so let's see, let's try to increase. This is again a keyword argument. No voice. Ajay is saying no voice. Is everybody able to hear me? Ajay, I think you have a problem. I guess you have a problem. Ajay, can you hear me? Okay, somebody please ask Ajay, write down in the chat window to disconnect and connect back again. Might be he have some internet issue. Please do that for me. Okay, so this is again the second keyword argument that I have. So what does this do? Okay, so when I put the value, you will notice the difference and you will know it on your own, that what exactly this argument is doing when I pass the value. Let's say I pass it 10. Now, did you notice what exactly this thing is doing? I guess you did. Yes, absolutely. Everybody did. So it's basically increasing the width of this line that we have. So in this way, you need to play around with these different arguments. Then only you'll be able to understand what exactly they are doing. Because going at the documentation and reading it for a beginner, it's a headache. I'm being honest, it's a headache, but that's how you learn. But what you can do, you can go there, you can get the arguments and you can try out according to yourself, and you can try out different things. Stick to one, and one of the, maybe you can pick one plot, and then you can go the arguments. What are the arguments it's taking in? You can try to explore them on your own. Of course, it's going to take time, but that's how we learn basically. So somebody asked me, so if I want to use some customization, I want to use my color. If somebody is aware of hex code, are you aware of hex code? Because somebody asked me this thing, in the previous sessions, that so can I use a hex code for the color? Okay, not aware of the hex code. Okay, so let's Google it up. Let's take help of Google hex code. Let's see. So basically, hex code is used for the colors. Basically, every color will have some hex code. So this is again a small crash course on design. So basically, this is the website that we have if we want to choose colors of your own choice. That is flatUIcolors.com. So you can go to any of this section. Maybe I can go to this British palette. Then if I go now, let's say that I want to use maybe which color to use. Maybe I want to use this color. So if I go and click on copy, this is going to give me the hex code. Basically, this is the hex code. So if I go and type this hex code and see what happens. So I can have any color that you can imagine in my line. My line can take up any color. So this was one of the website. Again, this is another amazing websites that we have for the color code. If somebody wants to use the customization with this website, you can choose multiple colors. So let's say I want to make a combination maybe of pink and blue. You can see this is what I get. I can maybe choose this one. If I go back, put it here, run it, this is something that I get. It's I mean, it has a very good contrast. And also you can choose any color. I mean, there is no restrictions on that. You can choose any colors that you want. Whichever color makes your graph looks good, choose that color. Go ahead with that. Yeah. So I'm gonna stick to the basic color that I have in the previous chart, so that it should be the similar one. Yeah, this is the color I opt for. So did you get this output? Or if anybody having any errors, please let me know. Otherwise, we can proceed further and explore the other methods, other parameters. Everybody is doing this, right? So I'm assuming all of you are doing this and we all are on the same page. If anybody have any difficulties, please let me know. I'm going very slow so that you can do this thing side by side. Now so I've plotted my data. Now I just by look, if some now I'm explaining you that you have seen the data and basically what are the values you have on the axis, what are the values you have on the y-axis. But somebody who haven't seen your data, they don't know basically what is the value on the x-axis, what is the value on the y-axis, and even they don't even know what this graph is all about. So we have to give the title to this particular graph. We have to tell about the x-axis, we have to tell about the y-axis also. Now this is going to be a challenge for you. You tell me, how can I plot the title for this graph? How can I plot the something to write on the x-axis? How can I write something on the y-axis? You tell me. Because we have already drawn this graph. If you need help, you can go to documentation. I know it's going to be tough, but give it a try. If it doesn't work out, I mean, that's fine. That's completely fine. Like, we have different parameters, so we need to find out that parameter. Can you do it, or should I do it? Guys, can you do it or not? Guys, can you hear me? Okay, how are you gonna give it the title, Sayed? Yeah, give it a title. Yeah, what is the title? Title, I also need a title. Yeah, so I have average maths test score. So does it looks good? You know, you are saying LSD, then underscore ppm. Does it looks good? I mean, just look at it. I'm not saying anything. You just tell me. Does it looks good? If you are showing this to your client, I mean, does it look good or not? Please type yes or no. Okay. Okay, let's try. Ashima's plot is also the same, but let's try anyway. I'm right. What? Sayed, I'm right in what? So this is Ajay gave me. Let's try Ajay's code. If it is makes sense or not. Yes, it does make sense now. A little sense. Yes, yes. You can see he's giving it to be as lowercase LSD. So these are the small things that that you might think doesn't matter, but they does basically. They does matter. So let's try to see. I'm not saying anything. Let's try, and then we'll notice the difference. And you tell me, does it matters or not? Now, does it look good? Maybe make it better. Okay. So tell me, guys, is it good or should we do something else also, making it better? What exactly I am doing here? Look at this. I'm giving a title. Does your client know what is LSD? Does your client know what is LSD? What is this time basically? Client is, I don't think so. He know and he, right? So we've got to give it a little clarity on this if we can. Obviously, if the client is from that particular domain, then obviously he must be aware. He should be aware of all those things, but we assume that he doesn't know. So we tell him all what we can. So time, I'm saying time in minutes. Then I'm saying tissue LSDs, something. Tissue LSD ppm. So obviously, if the client is coming with and asking me to do the analysis of the data, obviously he must have some knowledge of that particular data, what that data is doing. That's why he came to me and asked me to do the analysis. But I want to present it in that way so that he can understand it just by looking at it. I don't need to explain anything. He can just see, oh, okay, this is the time in minutes. Okay, this is tissue LSD ppm. I see. Got it, got it. So what is happening with it? Okay, it's increasing over time, right? This was the experiment, right? To increase the LSD with time. Okay, at what point it keep it like it's stagnant, the value is stagnant. After 1 hour, I mean, yeah, close to 1 hour, the values are like stagnant. They are not increasing with that amount. Can you see? And before that, if I say at this particular point, the value increased exponentially. after 30 minutes to 1 and 2 hours, basically you can see they increased with some dips, they increase exponentially, you can see that. So in that way you can explain this to the client. plt.show. So I haven't used plt.show and still I can see the graph. Let's notice the difference. When I use plt.show, what happens? Apply plt.grid. Yes, let's apply plt.grid as Ajay says. Yes, so we can have it in a grid form. It gives me more clarity at what point it is intersecting it. See? So Ajay, tell us, how do you know about plt.grid? How do you know about this? How did you found out about plt.grid? Have you looked into documentation? Have you read
It is
some
just of my
blogs?
interest. It is just of my
No,
interest.
no, that's completely fine. I mean, I'm just asking for others so they can also, you know, explore. How did you come to know about this? So you went to the documentation of matplotlib? Yes, so guys, see, that's how he knows basically. So that's how everybody knows, you know. That's how everybody knows. That's how I know all these functions, by going to the documentation. And Ajay, tell us, you know, how long does it takes you to understand the documentation, please, for everybody's understanding. How does it takes, you know, how many days, how many hours, how many minutes does it takes for everyone, you know? Ajay, can you tell us something on this? No? Okay, fine. So see, he spent like 4 or 5 hours. I mean, so visualization is a very important aspect, you know, looking at your data and putting it in different format. I mean, in scatter plot, bar chart, violin plot, there are different plots that are available in Matplotlib. I mean, maybe more than 100, I would say, more than 100 or more than that also. So you have to explore them to know about them. You cannot remember all those plots. No, that's very tough. You cannot remember all the code. You always have to refer documentation. So if somebody is thinking that, do I need to remember this? You don't need to remember this. Once you go start coding, and once you're doing the same thing again and again, I mean, obviously it clicks now, it clicks over time. But if you think you're gonna do it for maybe a day or two, then you want it to click on that particular point, that's never gonna happen. So obviously it's gonna take time, and you have to do hard work for that. You have to work for that. You have to spend time for that. You have to explore the documentation, try out different things. That's how we learn. That's how Ajay learned. I mean, we have an example right here in front of us. So we want to do more with this graph. This is not looking that good. I mean, I want to increase the, you know, the width, you can say, or the size of the text, or the font size. I want to increase the font size. So what do? I will pass a parameter which is the font size. So if you go to the documentation, there is a parameter which is a font size. So I will pass this parameter. Let's try different font size. Let's give it 20. So that's that's very huge. It's coming out of my graph. I don't want that. So let's make it like maybe 12 or 15. Yeah, let's try this. Yeah, let's make it a little small. Yeah. So I also want to give them the name, you know, this one and this one also. What do I do for that? I also use the same thing. I use font size. Can you see the difference? I guess you notice the difference. again the font size for right. So this is what I have. So I want to do more on this. So can you tell me, I want to limit the values of this. So let's see what is the minimum value for my LSD and what is the maximum value. So the minimum value for the time delay is 5 and for LSD is 1.17. So let's say take it 1. Minimum value is for LSD 1 and maximum value for time delay is 480. Let's call it 500, and for it let's call it 7. So I want to have my values of x-axis and y-axis between 1 to 7 and 5 to 500. How can I do that? Please help me with the code. What do I write? Ajay, you will not reply, please. Let everyone, take their time and they will reply. Please, Ajay, you will not. If you want, you can reply to me personally. So I want responses from everyone else. You can try it from your end, Ajay, on your end, on your notebook. Okay. Yes, yes. Yeah, go ahead, go ahead. Try it. So Sunidhi gave this to me. So Sunidhi, when I apply this code that you gave me, this is what I have. What about the others? They can also try, I mean. Nobody wants to reply. Okay, cool. So what are the values that I want on my x-axis? First of all, let's try to understand that. On my axis, what is the minimum value that I need? On my x-axis, first of all, I have time. So my minimum time starts from 5 and goes up to 500. Starts from 5 and goes up to 500. Then my PLT dot volume, it starts from 1 and go up till 7. Let's make it 0 maybe. Okay. No, it's not. It's cutting out the values. Some of the values are cutting out. So maybe what should I write? Yeah, let's keep it 0. I mean, we are missing some values. Yeah, and also for volume, let's start from 0. No, 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 no. I have to use it from 1 to 7. Yeah, it's much better, I guess. Okay, cool. So yeah, I'm able to limit the values by using this function xlim and ylim. So on x-axis, I need from 0 to 500, and from y-axis, I need from 1 to 7. So I have now limited values that will take place in this particular graph. Now what else I need to do? Let's look at this function. Yeah, it's done. Okay, let's say I want to insert a footer to this graph. So how can I do that? There is a function that I have that I can use the footer, which is plt.text. So I will break it down, but I guess you will understand it. It's very easy. Let's give it maybe some other value. Let's maybe then you can understand. 5. Let's give it 5. Let's give it 5 also. So S means a string basically. I'm passing a string. Font size means the font size. If you want, you can just delete it. But yeah, just delete it for now. I mean, then maybe you'll be able to understand. Did you notice the difference? It took the text and placed it at 5,5. But I want it as a footer. So what I'll do, I'll make the value as 1 comma maybe -5. So let's see what happens then. It will go out of my graph. I don't want that. So what I will do, I will say 0.5. Okay, this is what I have. So what else to do? I mean 0. Yeah, make it 0, not 1. Yeah, so I have it somewhere here. Okay, I want to keep the text as same. The font size should be the same as all of the others. So what do? I'll uncomment this out. So this is what I have basically. So if you want, you can also apply the grid. This will give you the grid. What else to do? Yes. So if I want to increase these values, the size of these values, 1, 2, 3, 4, 5, and 0, 1, 2, if I want to increase the size of these values, what do? I use X ticks and Y ticks with some font size. So now I guess you are able to notice the difference. You can clearly see the size difference. So Ajay, can you tell us how to apply ligand on it? plt.ligand, how to apply? Okay, let's try to see what this ligand does. Handle with label, no found ligand. So let's try to explore this. So whenever you want to use something, I mean, it places a ligand on the x-axis. So we need to pass in the values for the ligand where we want to place the ligand. The call structures correspond to the 3 different ways used. Automatic detecting the element to shown in the ligand, the element to be added in the ligand, and automatically determined when you do not pass any extra argument. In case the label, so this is the way that we can use and for line when we are plotting a plot, and if I have some label, then I can use the ligand. So in this case, Ajay, I guess we don't require ligand to apply, because you can use it in case of line graph, I guess, line plot that you have. It automatically picks up the values. You don't need to pass any arguments. That's what I think. Or you can pass some labels if you want. Handles and labels you can pass. So let's try to pass something. Let's see what happens. Okay, let's maybe pass a label which is LSD. Let's see if it's take the string or if does it give me error. So yeah, did you notice any difference?
I have this value. If I go comment it out, it got removed basically. If I may say maybe time. So this way, you all can also play around with it. I mean, and try out things that what is this function is doing? Should I use it? Should I not? All sort of things. So this will not have a ligand. This will not work. Then now we are almost there. We will just use a style basically for our graph. We have a grid. I mean, it's also not required. I mean, you can, if you would like to use it, you can use grid. We'll see what are the different styles that are available for Matplotlib. Matplotlib style. So we will go and use one of the style sheet reference, style gallery. So yeah, these are the styles that we have available for the Matplotlib. So you can draw this sort of visualization by using Matplotlib. Can you see this sort of visualization? It's all possible with this Matplotlib graph. So I'll encourage you, if I click on maybe any one of them, they will tell me how they work basically. Also, they have divided them into sections. This is the style BMH. This is the classic style, then a dark grid. So I will be using, I'm trying ligand function in Matplotlib. Okay, no, I'm reading the plan. So this is a dark background. This is a 538. So how do I use this different style, in my chart basically, in my graph that I have? So I will say just this one single line, which is plt dot style then dot use, and I will pass the name of the style that I want to use. Maybe maybe I want to use ggplot. Okay, so if I go, so see this graph, and when I apply this style, notice the difference. Okay, I think it didn't run very well. Yeah, can you notice the difference? Okay, let's try some others as well. Let's say maybe what we want to try is, let's try this. This looks good. So this is what I get. Does it looks good? I mean, personally to me, so I will say no. Maybe, yeah, maybe for someone they might like it, but I'll go with the classic style. So you can always explore, these all the sort of different things you can always explore. Okay, it didn't run. Yeah, so I just want to keep things simple. So this is the kind of style that I am looking for. Yeah, this is what I have here, and this is what I want here. If somebody is interested in more, different type of styles, I mean, they can surely refer to these. Maybe you can try BMH, and let's see. Yeah, so this is how it looks. I'll stick to classic. Yeah, so that's it for this graph. Now what we'll do, we'll take a break. So before that, if anybody have any questions, you can ask. If any one of you have any questions, you can ask. Next thing we are going to do, we are going to apply a linear regression on this data point that we have. Nobody have any question? So let's take a break for 15 minutes, have some glass of water, coffee, tea, whatever you like. And then once we jump back, we will apply the linear regression, and we will try to visualize our data after applying the linear regression. As you can see, oh yeah, this is what we are going to do. Yeah, 2:35. We'll be back by 2:35. 33:35. Okay, great guys.
So everybody's back. Can we start our discussion? Okay, cool. Can you see my screen? Okay. Now we will be applying the linear regression on this data point basically and trying to predict the best fit line that can fit these data point. So I'm going to break down this code for you and then we'll try to visualize that data. How can we, whatever the value that we have predicted and the original value for the LSD values, we'll try to check them. How far we were, how accurate we were, okay? So I'm going to break down this code for you. So first of all, I will create a function which I will call regger, and I will have the linear regression method or a class stored in this object basically. So what exactly I'm doing at this point, I am calling the functionality of a linear regression model from the matplot or sorry, the scikit-learn library. I have imported the the linear regression model. When I say from sklearn.linear model, I'm importing linear regression basically. So I have imported that linear regression. I am storing it in this variable, which is regger. Now, if I want to use it, I have to use the regger only. I don't have to call every time linear regression, then pass in the parameters. I just use regger. Now, if I run it, so the next line, what I'm going to do, I'm going to say regger dot fit, and I will pass in the parameters on which I want to fit the value basically. So I want to fit the value of score, and I want to fit the value of score and what do you call it? LSD basically, LSD and score. How these scores are getting affected with the concentration of LSD. So this is so how do I define LSD? LSD lowercase, LSD and score, yeah. Okay, now can you see I have this big error and it is saying expected 2D array got 1D array. Reshape your data by using -1 single feature blah blah blah. This error I'm getting. So can somebody tell me why I'm getting this error? What could be the reason? Can somebody tell me? Ajay, can you tell us why we are having this error? Not exactly. Okay. So I am getting this error because of the LSD value, right? So let's check how I stored the LSD value. Let's look at the LSD. So I am storing the LSD value this way. So can somebody tell me what is the type of LSD? What is the data type? If I extra, okay. Let me put this question again. String. String, okay. Okay, I have this data. I'm going to check the type. Okay, Sunidhi, you tell me first of all. So you think this is a string. So what is the type of this data that I have? What is the type of this data? Everybody also, I need responses from everyone. Yeah, she's saying data frame. What about the others? What do you think? What is it? What exactly this is? This is data. This is data frame, right? So yes, it's a data frame. So this should be also data frame, right? When we did all other operations, extracted single column, double column from the data, I told you that there are two ways to extract a column. You can extract a column in a series, also you can extract it in a data frame, but always try to extract it in the form of data frame, otherwise it will lead you to error. And I said I will point out to this thing in the future lecture. So somebody tell me please, what is the type of this LSD that I have? Is it a data frame? It's a series. So how can I make it? First of all, let's check if somebody is not clear that whether it's a data frame or series. Let's check the type. So yes, it's a series. So tell me, how can I make it a data frame? Double. That's right. That's right. Absolutely. So I need 2 square brackets. That's the only way I can make it a data frame. Otherwise, it will keep giving me errors. So always keep in mind whenever you are, I did this mistake, so that I can teach you this, this is very essential. When you are applying any model and you are using your data, one is in the series, so then that is going to lead into problem. You might have to do lots of manipulation, and still it will lead you to some other errors. You solve one error, it will give you some other error. So let's check. Don't trust my words. Let's check. Now, is it a data frame? It's still a series. Run it. Now it's a data frame. Yeah, now it is. Now that means I can go and I can run it. So when I ran it in the form of data frame, I did not get any errors. Is it clear to everyone? I hope it is. Now I'm going to get the coefficient basically of the rigor. If you can remember, do you remember what is coefficient, what is intercept, or do you forgot that? You remember that? I hope all of you remember what was coefficient, what was intercept basically. So I'm calculating the coefficient. Great, that's great, lovely to see that. Now let's calculate the intercept. Yeah. So can I access the single value from it? Is it possible to access the single value? This is inside the array. Can I access the value only? I need the value only. Is it possible to access this? Yes, Ajay, absolutely right. Somebody tell me, how can I access minus 9.000946? How can I access it? If you can remember indexing, I taught you indexing. This can be done with the help of indexing. So tell me how to do this. Yes, put it the indexing of the data frame. I know. I'm asking you how to do that. Nobody knows it? Okay, fine. So what I did basically, okay, let me reverse it. So this value is inside a list basically. This is an array and there are two lists. So first of all, I have to get enter to this list basically. When I do this, I will get this output. So still I have one list. So I also want to enter into this list and access this value. So how can I access the value from a list which has only one value? Just by passing 0 index. This is how I can access it. But in this case, I only have one list. You can see one square bracket. So I will only use it for once. Run it. Cool. I will also use the R score. I will say Regger dot score. Basically, I want to score the scores. Do you remember this R score? We had this term R score that we were predicting. This tells me about the accuracy, how well my model is doing. So I am getting the 87% accuracy. So if I want to use the print formatting here, how can I do it? I can do it this way. Theta1 intercept R square. Okay, my bad, guys. Yeah, this is what I can do. Right? So if I want to make the prediction, how can I do it? There is again a simple function that we use for the prediction. I want to store the predicted score, right? Predicted underscore score. What I will do, I will call my function Regger dot predict. Use the tab key. No, I don't want to use the predicted score. No. So you can see this Regger has lots of function. So I'll use the predict function. What I will pass in this, I will pass the LSD scores that I have. Based on the LSD score, LSD, that is tissue concentration of the drug. Based on that, I am predicting the score. LSD. Now, if I go and try to predict this, I mean, print it out. Let's say print it out. So these are the scores I am getting. Let's print the actual scores that I have. I've stored it somewhere in a variable. Where is it? Yeah, score now. So I'll show you both of them. Maybe you are able to notice the difference. What was the actual score and how well our model predicted them. So the actual score was 78.93. Our model predicted 78.52. The actual score was 58.20 and our model predicted it 62.36. The actual score was 67.47. Our model predicted 59, 37, 46, 36, 45, and 35, 32, 29, 31. So that is why we are getting the accuracy or the R square of 87.77%. So do you guys follow what is happening here? Do you guys follow this or not? If you don't follow, that's completely fine. I mean, everybody does follow. Amazing. Okay. Now I want to plot this graph. These are my data points. Okay. My data points and the predicted score. This is the line, which is the predicted score. With the tissue, I have tissue per ppm here and the score. This is the actual point. This is the actual point predicted. Do you remember this line when I showed you the slide? If you can remember it, there was the slide. Yeah. Do you remember this? Actual point predicted, actual point predicted, actual point predict. Sorry. Wrong. Actual point predicted, actual point predicted, actual point predicted. Same line I am getting here. Because visualization is always helpful. Just, because you cannot trust my words, whatever I'm saying, you cannot trust that. You obviously need some proof. So here is the proof and we are going to draw it. this line of code that I have here. Yes, one thing was left. In the last code. Yeah. What does this do? This matplotlib.inline. I didn't explain you about this. What exactly this line do? Did I told you about this line? What exactly this line is doing? In the last plot that we have drawn? Or if somebody know what exactly this line does, please tell me. If Ajay, are you aware why we use this percentage matplotlib? Okay, please tell everybody.
Percentage will help us to draw the graph here only.
Okay, if I don't have the percentage.lib, then what happens?
Then the graph will come in the next pop-up menu, pop-up window.
Next pop-up window. I mean, okay, let's see what he's trying to say. PLT is not defined. What happened? I have to run it, I guess. No, wrong. I'm on the wrong page. Yeah, over here, nah. So here, okay, problem. Just hang on, guys. Just hang on. I'm gonna have this line. Okay, so can you see? Is it okay, Ajay? Is it coming in the same window? I did not understand the concept of pop-up window, next window. Is it coming in the same window?
Yeah, same window. Actually, I don't know the purpose of putting percentage matplotlib.
Okay, you don't know. Okay, anybody knows what is
Sorry.
the? That's fine. At least you tried. I mean, that's fine. Yeah.
Hmm.
Anybody knows that why we are using matplotlib percentage matplotlib inline? If you don't know, that's completely fine. So that is actually not the purpose of matplotlib.inline is basically why we use matplotlib.inline. When I go to file, when I try to download this file as ipynb file, I want to make sure whatever the graph I have drawn on this line or in this notebook, they should stay there. I don't have to go and run this code again. Maybe what happens is that I might download this file. I might take this file to my work computer. And at that work computer, I don't have, all these files available. Might be I'm using different files. I don't have these files. And I want to present this information to my client. So how can I do that? I want to retain the graph now. So this percentage matplotlib.inline helps me to retain the graphs. Whatever I draw there, it stays there. That's what it means when I download it as ipynb file. Okay, graph will be there itself even if the file is downloaded as ipynb. But that's what the purpose of matplotlib.inline is. That's what I believe, and that's what it is. Maybe it could be something else. But that, according to my understanding, this is the purpose of matplotlib.inline. The graph stays there. I mean, you can try without this, and then tell me, correct me. I mean, if I'm wrong, you're welcome to correct me. Maybe I'm wrong, but this is what according to my understanding, this is what I feel. Okay, yeah. So now we want to plot this graph basically. The second graph that we have, which is okay, there is problem here. So I'll take this graph, I'll plot it, break down the code for you. So I guess these lines are clear. Title is clear, font size is clear, X label is clear, Y label is clear, X lim and Y lim is clear. If not, that's fine. I mean, so first of all, what exactly we are doing? We are using two graphs here. Let's try to understand what exactly we are doing. We are using two graphs. Sorry. Okay, leave the alpha and all. Leave them for now. Okay, hang on. Okay, so what is this doing? This is called a scatter plot. So what I am doing basically here, over here, I have the concentration, LSD concentration on the x-axis, and over the y-axis, I have the score basically. I'm scattering my points all over my graph basically with scatter plot. That's what I can do. I can do the scattering. So maybe for the LSD concentration, which is close to 7, I have a score around this, which is 33. And I guess I have shown you that already. Yeah. Can you see? Close to 30. No. Yeah, 30 and 33 then. Then this 33, this is 55 something, 65, 78 or something. Concentration is very low, 1.25. Then the concentration is close to 3, then it is above 3, then it is 4.7 or something. It's less than 3, sorry, less than 6, less than 6, greater than 6. So this is what it's telling me. These are my actual points basically. I want to plot my line. I want to plot the line and check how far the line that I have, the points that I have predicted, how far they are from the actual points basically. So I want to give them a color and I want to add the alpha value. So this color will give this color. If I go and write it as color, if I go and say color is equal to blue, run it. I am sorry, I have to pass them in a string. I'm so sorry guys. Yes, so it's a blue color, and let's see what S does. S is another parameter that I have found out. If you go to the matplotlib scatter, you'll find this in documentation. Scatter. So these are the S. What exactly S is doing basically? It's giving the size. It's for the size of the points basically. So I'm gonna give it a size maybe 100, or let's give it maybe 500. So you can see I don't need this big size. I mean, I can make it small. So I've tried multiple sizes and I came up with the optimal, which is 100, which looks good. I mean, this I want to decrease, I want to, decrease the intensity of the color. What do I do? Make them transparent. I'll use the alpha. So see, did you notice the difference? If you don't, then okay, let's make it 9. And it's also mentioned there about alpha value. Yeah, it can take value from 0 to 1, blending the value between opaque, transparent. This is for opaque value, this is for transparent value. Then I have line breadth also there. Is it clear? I mean, should I stress more on it, or is it clear that it's transparent basically? All right, now let's give it a title. What is this graph telling me? This graph is telling me the arithmetic score versus the LSD 25. Yes, what we have on the x-axis, we have the LSD concentration, tissue of LSD ppm. See, the font size is giving it a size. I've given it the same size, 17. It's a little bigger, and it's 14. Now let's give it a Y label. So on Y label, we have the performance scale. So I'm gonna keep it 14. you want, you can change the value. So now I want to limit the value from 0 to 7 I have on the x-axis, or I've given it from 1 to 7.5, and from I have values like maybe from 25 till like 85. Yeah, so this is again a kind of style that I found, and I'm going to use this style. Let's see, this is what it does. Just hang on. Yeah, this is the style, and it looks way better. Does it look better, or the other one was looking better? Let's notice the difference. No, it didn't run. Oh guys, it's not working. So sorry guys, it's not working. Oh my god. Okay, so it's look way better. It's not actually working. I have to go interrupt the kernel, then run again all the cell, which I really don't want to do right now. Now if I want to plot my line, I need two values. Basically I need the LSD value and the predicted score. So here I have the predicted score, which is going to pass on the y-axis. Then I have the LSD value, right? So this is what I am going to do with the plot. So I'll uncomment it out. Okay, LSD. This is what I get. And I guess this looks way better. And this is the same, I mean. Cool guys, anybody have any doubts? Please ask if you did not get anything. I try to break it down in smaller chunks so you can understand it. Cool with everyone? Now, okay, let's jump back to the slide. I guess this is clear to everyone. Now we have applied our second regression model to it. And this is what we have calculated the value for theta 0, theta naught, and theta 1, which is my slope and intercept. So let's see what was the value which was predicted by those scientists. So this was the value. This was can you see? This is the theta naught value, which we call the intercept. This is the theta 1 value, which is minus 9.14. And how much did we calculate it? Intercept is 89 and it's 9. So our intercept is 89 and it's approximately 9. So I mean we are close, right? We are close to the value which they have predicted. We are pretty close to that. So they must have used some other parameters also, and they must have a very good computer system at that point in 90s. I mean, they must have a good system and another features which they didn't share with us, because they shared with us few features. This was Wenger and Fkjamin Bing basically. So what exactly they did, what exactly they used? So they used IBM 360 computer program, and this was a huge computer at that point of time which they used. And to be very honest, we don't know whether do they really used it or whether IBM paid them for this shout out. We don't really know, but this was published in the paper which I found, and I'm just sharing it with you. Now let's try to understand. We have applied our two machine learning models. Let's try to understand how exactly these model works, basically how they predicted these values, how they get a exact fit line, how they are able to predict them so very well, giving the accuracy of 90%. How is that even possible? How does that work in the backend? Let's try to look at that again. So basically what it does, what a model does, it predicts some values. What values? These values for the linear regression, we are predicting these two values, theta 0 and theta 1. We are predicting the value. Then what we do, we go and check the error. We calculate the error. How well I predicted than the actual value. Then we learn from those mistakes and we try to reduce the error. We go back and predict the value again. Then we calculate the error. We check how far we are away from our real prediction or the actual value, how far and what went wrong, why we are calculating it wrong. Then again, the model learns something from its error. It goes back, learn, again apply the model, make some prediction, and so on and so forth. This cycle continues until we attain a certain level. But that's where the real question comes into picture. How do the model exactly knows that this is the best point for it to stop? Because it is only calculating the theta 0 and theta 1 value, right? It doesn't know where to stop. So if the time permits, we will look into it today. If not today, we'll look into it tomorrow. By visualization, we'll create our own algorithm for that, for doing all these things. And with the help of visualization, I'll show you what exactly happens at the back end, how these values get calculated, how the errors get calculated, how the model come to know that this is the point it have to stop the iteration. This is the best value it can achieve. So we'll look into that tomorrow. So basically, what is this? The structure that we have seen, what is exactly this? What we call it in scientific way? We call it algorithm, right? So what does the British dictionary says about it? The Cambridge dictionary, what does they say about it? So they say algorithm is a set of mathematical instructions or rules that, especially if given to a computer, will help to calculate an answer to a problem. That means if I gave an algorithm to my computer, if I give it some data to apply that particular algorithm, then it might solve a problem for me for future. In this case, that I predicted that yes, there is a effect of drug concentration on the math score, the survey which was conducted. So maybe if I know the math score, then I may find the correlation between these two. And maybe if I know the the concentration of the drug in the tissues, maybe I can calculate the score, that if this is the concentration, this is the amount of score he should get and how much score he achieves. So in that way we can look at it. And we also hear this word a lot, when we see, like, some people say my app uses an algorithm to predict if fans of one particular band will also like music of another band. So you might have heard this, like Uber says or Ola says, our algorithm gives you the best pricing. Basically, it works on the pricing algorithm. As Google says, my Google map algorithm works in a way, it calculates the least distance, finding the least distance. That's how it works. So in this way, so this word, basically somebody used this word. A word is used by basically a programmer when they don't want you to explain what exactly they did. Now if I tell you something, that I have built a model with which I can predict the gestures. If you will show some gesture to the application that I have built, that application is going to recognize those gestures. Maybe Indian Sign Language. I'm working on a project, let's say I'm working on the project which recognize Indian Sign Language, and that is a problem, I guess. If you go and research about it, that is a problem with Indian Sign Language. It is not standardized. We have different types of sign language in different region. If I talk about ASL, that is American Sign Language, we have already a model which is built for that, for recognizing the different features. For the words, they have signs for the words. For the letters also, they have the signs which are already made. So let's say what I tell you is, I have created a model which recognize the sign language, basically Indian Sign Language. So what do you understand from this? So you just imagine, oh, this is very cool. I mean, yeah, you must have done something, great. But would I tell you what exactly I did? No, basically nobody's going to tell you that what exactly they did. And that's when people use the term algorithm. That is, it is something which they don't want to share with you. They want to sound cool. Obviously they are doing something cool, but they also don't want to share this information with you. because then maybe some other day you might come up with a better algorithm, and where things might get obsolete. So this is what the term algorithm is basically. So algorithm is basically a mathematical function which my computer tries to learn. Based on that function, it tries to give me the predictions. I have maybe some equation, maybe 5x plus 2 equal to y maybe, or some other equation. So I try to solve all these equations and try to find out the relation between them. Is there a common equation that I can use for all these different question that you are giving me? Can I make a standardized equation that I can use to get the answer for all these equations? And this is what basically the algorithm does. And while it is calculating that particular equation, as we say function, when we are finding out the function basically, so it will make the errors, it will make mistakes, and it will try to reduce those mistakes, it will try to reduce that particular error. But the important thing that comes into picture, when the model, when the algorithm, when the computer program is going to know that this is the point I should stop, this is the best answer for my model. You solve a problem, obviously you have maybe you're solving some mathematical problem, you are solving a question, you solve it, you get the answer, and you check your answer is far away from the actual answer. Maybe the actual answer is 100 and you are getting maybe close to 60. So you go, oh, your answer is coming out to be 60. What you should do, you should go back and do something else. Then you come back, solve it again, maybe next time you get 65, and you do this iteration, you go back, solve it again and again, and maybe at a point you reach that you get the answer maybe 95 or 98, and the next time when you go try to solve it, you get answer 65. Then you realize you have to stop and you have to you have to consider your last answer, which was 95 or 99. So because it is close to the original value, but the model, the machine doesn't know this. So there has to be something which the machine is doing at the back end, with which it is able to recognize that this is the point I should stop, this is the point I should not do any more calculation, this is the best answer for me, I'm not going to do any more calculation, right? Otherwise it is going to keep on continue doing calculation, and we don't know which is the best answer. So we will try to look at that, how does that work basically. So how does it work? So let's try to understand it from scratch again. I think we have looked at this at the first day. Let's try to look at it again. So I have different points basically, so I want to find the best fit line that I can just give me a second, guys. Let me connect it to the charger. Give me a second. So are you guys following what I'm trying to tell you? I'm just building the intro for tomorrow's lecture. I hope you are understanding that I'm trying to tell. Cool, everybody's getting it, great. So tomorrow's lecture, we're gonna jump into the depth of the machine learning. How does it actually finds out that this is the minimum value for my parameter, or for my theta naught and theta 1, for my intercept and slope? How does the model knows? How does the machine knows? We look into that tomorrow. So basically what we want to do, we want to find out the minimum value for theta naught and theta 1, that which value is going to result me the best fit line. This is what I have told you so far, but there is actually much more than that. I mean, so we'll look into that. How do the model know this is the best value? That is the question. How does the model know which is the best value, right? So we will look into that tomorrow maybe. If I show you this picture, then you might think, yes sir, it's very visible. I mean, anybody can look at this picture and can tell me that this is the
not a good line. I mean, it's giving me more error, and this is a good line. It's giving me good error, but actually there is much more than that which is going on in the background. So basically, what we are trying to do in simple terms, the intuition that I gave you is basically we are trying to reduce the error, and that's what actually is going on, right? We are trying to reduce the error which my model is making. But again, the same question comes into picture. What is the stopping point? Where should I stop? So I will answer that tomorrow. So this is just a recap. If somebody forgot something, this is just a recap. The minimization problem we are trying to tackle by using the residual sum of squares. We are trying to minimize the error, maximize the accuracy. We could have a adverse problem. Maybe we want to maximize profit. You want to minimize the cost. We could have different type of problems now when we are dealing with any machine learning model. So we have to, but the loss is always going to be minimized. When we talk about loss, this is the loss, right? This is the error, as we say. This is the error, but always we will try to minimize this error. So then tomorrow what we're gonna do, we're gonna talk about the cost function. So how can we minimize this error? Is there a way that we can create some function which is going to tell my model, which is going to draw some equation with which I am able to minimize my error? So that is called as cost function. So there are others. This is again a new jargon for you in vocabulary of machine learning, and we call it sometime cost function, loss function, error function, objective function, because this is used in cost function is used in all different fields. Objective function is all different fields. Like objective function could be maximization function, could be minimization, as I said, maximizing profit, minimizing loss. Error function could be minimizing the error. Loss function is again minimizing the loss. Cost function is basically calculating the cost of finding out the minimum error. That is the cost function, or simple term you can say we are trying to find out the point at which my loss is going to be minimum. So this function will tell me about that point, that at this point maybe okay, hang on, just hang on guys. Yeah, so we will look at this point tomorrow maybe. So this is basically my cost function. Okay, this is basically my cost function. This is just intuition that I want to give you right now. This is my cost function. So what is the point at which my x is going to be tomorrow? Objective function, cost function, loss function, error, they all are same. These are basically names which you will hear or which you will read when you go online, when you read different articles. Somebody say it's a loss function, somebody say it's a cost function, somebody say it's an error function, somebody say it's an objective function. These are the different names which are given. So what we want to do, let's say this is my cost function that I have. So what I want to do with the cost function, I want to minimize the error. So the error minimize, what is the minimization error? At this point the error will be minimized. So I think that's it for today. I mean we should not talk more about this, otherwise it will just bounce off your head. So let's just keep it simple for today. We will talk about this tomorrow, if that is okay with everyone. I guess everybody will agree to that. Okay, so anybody have any questions, you can ask. I will share the notebook with you for the Python intro notebook. You can go ahead and you can try this out. If you have some question, maybe we can discuss them tomorrow. If anybody have any questions, anything related to anything that we have covered so far. So you can ask. Python intro is done. Ajay, you haven't attended the previous 2 classes? It's done. Python intro is done. Yeah, I'm sharing the notebook in which we've covered those topics. Okay, it's okay. No, it's not a book. I mean, it's a notebook, Jupyter notebook, as we say. So guys, go and practice all these different functions that you are exposed to, and it will take some time.